Good morning, good afternoon, good evening, everyone. Welcome to AER Live, a new series of online interactive workshops from Applied Ecology Resources, or AER. I'm Mark Cadott, Chair of AER, and I'd like to thank everyone for joining us today for this month's workshop. AER is a globally accessible open platform that makes preserving, sharing, and discovering applied ecological information easier for everyone in the ecological community. We are broadcasting these free online workshops for applied ecologists around the world as we prepare for the launch of our fully searchable database on AER later this year. At the heart of AER is our open access journal, Ecological Solutions and Evidence, which is part of a cross-society special feature on the decade of ecosystem restoration. We would like to encourage restoration managers with examples of successful restorations, restoration methodologies, or pressing issues in restoration practice to contribute from practice or perspective article types in our journal as part of this exciting collection. As part of your journal submission, authors will also be able to archive any reports or technical documents connected with their article in AER for long-term preservation and discovery. Please visit bit.ly/restoration papers call to find out more. We'd like to thank our two sponsors for this month's AER Live, Ecology Resources Limited, a specialist ecological consultancy firm who fund the BES's Ecology the Next Generation bursary scheme. This bursary scheme supports 4 young ecologists from low-income backgrounds to study and begin their careers in applied ecology. And also NHBS, our other sponsor, the UK-based supplier of books and equipment for ecologists. Details of their services and their exclusive offer for AER Live viewers are provided in a slide at the end of this workshop. I'll shortly hand over to our speaker, Dr. Nancy Ockendon from Conservation Research Institute at the University of Cambridge, who's giving today's talk. But let me first quickly say that we are recording this talk and we'll post the video online. During the workshop, there'll be a few interactive elements we would like you to participate in. And importantly, if you have any questions you would like to ask Nancy, please submit questions anytime during the workshop using the Zoom chat box. We'll pick a couple of these to ask our speaker during the Q&A at the end of the talk. So without waiting any longer, let me introduce today's speaker, Dr. Nancy Ockendon, and her talk, Designing Experiments to Improve Conservation Practice. Over to you, Nancy.
Thank you very much, Mark, and thank you to everybody for coming along and listening today. I'm going to talk a bit about trying to integrate more experimental components into conservation practice, how we can look for opportunities to do this, to improve our understanding of what doesn't work in conservation, and then ultimately to make practice more effective. So as Mark says, my name's Nancy Ockendon. I work as the Science Coordinator on the Endangered Landscapes Programme, which is a programme that aims to restore Europe's degraded landscapes, mainly by funding large-scale restoration projects. And we're based in the Cambridge Conservation Initiative. And I'll talk a bit more about how we're trying to encourage experiments in our projects through the talk. So this is just a brief outline of what I'm going to talk about today. I'll first talk about why we need to do experiments in conservation and to do more experiments. I'll then go on and talk a bit about some of the barriers to implementing experiments as part of conservation practice. I'll touch on the importance of planning in advance and then talk a bit about experimental design and how to carry out effective experiments in the real sort of messy world of conservation. And finally, talk a little bit about what to do with results at the end of experiments. So I thought I'd start by carrying out a quick poll of the audience here today. And I wanted to ask you to think about whether you've ever carried out an experiment as part of conservation management or conservation projects. So I guess this isn't as part of, say, a research project or a course, but as actual sort of part of on-the-ground conservation. So if you work on projects on the ground, that should be fairly straightforward to answer. If you're working in more research or you're a student, maybe you could think about projects that you know about, or conservation organisations you know, and whether they include experimental components occasionally, never, or frequently. So I'm just going to launch the poll there. Okay, and I can end that and share the results. So thank you very much for your votes. So interesting results actually, and possibly more encouraging than I expected. So 18% of people having carried 7 out of you having carried them out frequently, which is great to hear. So it obviously is something that's going on out there, although obviously it could also be increased. So I thought I'd start by talking about why it's important that we do experiments in conservation. And really, experiments are the best way to generate evidence to understand the effectiveness of conservation actions. And this evidence can then be used in decision making to make more effective decisions, and in the end make conservation more effective. And this was really well covered in the Applied Ecological Resources talk a couple of months ago in September by Harriet Downey, who talked about the use of evidence in decision making. And there are still many gaps in the conservation evidence base, which mean that we can't always make decisions that are as well informed as we'd like them to be. Just to demonstrate this, I had a look at the conservation evidence database. So conservation evidence lists all the potential actions you can take for the conservation of taxa and habitats. And just as an example, I chose to look at conservation of peatland vegetation. And there are 125 possible actions you could take to conserve peatland vegetation. And conservation evidence does systematic searches of the literature to look for the evidence for each of these actions. And of the 125 possible actions, nearly half of them have no evidence at all. So for example, if we were considering, take the second example on here, planting a shelter belt to protect peatlands from wind, there's no evidence for us to base that decision on. We don't know if it might work or it might not work. And someone might have carried that action out in the past, but if they haven't shared the results, it can't be used to inform future decision making by others. So there are really big gaps in the evidence base, and this isn't sort of solely the case for peatlands, it's true across habitats and across taxa. And as well as there being big gaps in the evidence base, there's also biases. There tends to be more evidence relating to temperate systems compared to tropical systems, and for vertebrates compared to invertebrates. And these biases certainly don't reflect the conservation need, so it's not that threatened and endangered species or habitats have more evidence than those that are less of a conservation focus. In fact, often it's the opposite. So there are big gaps in the evidence base, and we really need to sort of extend it in terms of both breadth and depth of evidence for the effectiveness of conservation actions. So, as I say, experiments are a good way of generating evidence, and we need more to be carried out. And as I say, it's heartening to see the number of you who say you're already carrying out experiments, but I think we probably all could be doing more. So I was just going to do another poll to ask about the main barriers that are preventing experiments being carried out more routinely as part of conservation practice. And again, think about the conservation projects or managements that I referred to in the previous poll. And I'm going to use Mentimeter for this because that allows you to give more open-ended answers. So I think Erica or Min is going to put the link to the Mentimeter page in the chat box. So if you have a look in the chat box and click on that, it should open a browser window, which should take you straight to the question. And you can type in 1 or 2 words describing the main barriers, and hopefully they will pop up in the results. And you can put, I think you can add multiple answers. And if a word comes up that you think is important and you agree with, then you can retype it and that will make it bigger. It's great to see it's working for some people. Looks like funding, time coming up as really the key factors: money, funding, time. Confidence, interesting to see that. Time and resources, yeah, all relating to capacity. Right, I'll just leave that up for another couple of seconds. Brilliant, thank you very much. It's interesting to see those results. Yeah, so I think the time and funding are the key ones, but the complexities and organisational appetite, yeah, really interesting to see those results. And I will say that and look back at it, but I think the messages that are coming out quite clearly. Right. So I guess the next stage is to think about how we can start to overcome those barriers. And luckily, I expected that the most frequent answers might be about time and resources. And that's not unexpected. Across all of conservation, we're always stretched for time and resources. We always want to do more than we have the capacity to do. And I guess in this talk, what I want to encourage us all to do is to think about when there are opportunities at relatively little cost to include an experimental component in conservation practice, and trying to work out when the occasions are when we really need to act now. Often conservation is dealing with really urgent crises, and we might know enough to act and to act now. And when is it worth taking a step back and including an experimental component in our study, and then improving understanding, which in the longer term can allow us to make more effective decisions. I guess that although there normally is some cost associated with experiments, it doesn't always have to be big. There may be a bit of a cost in terms of thinking about planning, and in particularly in terms of sharing results. But often with a bit of minor tweaking, you might be able to generate learning without a great deal extra work. So one example might be, for example, if you had an invasive plant species on a nature reserve and you were going to treat it with a herbicide. If you maybe treated half the patches in March with the herbicide and half the patches in May, and monitored the effectiveness and the reduction in the plant species with time under those two treatments, you would have learned already which of those is more effective at decreasing cover of the plant, rather than just applying it at one time. And that probably isn't a great deal of extra work. Another thing to say about cost effectiveness is sharing results can really enhance that. So if you do your one experiment and apply the results in your adaptive management, you've gained some benefit. But if 20 different projects all carry out one intervention and test it and share the results, suddenly you're getting 20 bits of information for the one experiment you've done. And that makes the cost effectiveness look a lot more, I guess, positive. Another thing to say is that conservation donors are increasingly seeing the value in including experiments in projects. So this is a survey that was carried out of, I think, 17 or 18 conservation funding organisations, and they were asked what proportion of project funds they'd be prepared to allocate to an experimental component. And the most frequent answer was 1 to 3%. So I think that's saying that, yeah, funders do see value in this, and including an experimental component in a conservation project proposal should be seen as a positive thing. And as the Endangered Landscape Programme, as I say, we fund large-scale restoration projects, and we're actually asking all the projects that we fund to include an experiment and a test of an action as part of their work, and there's budget allocated to doing that. So hopefully that will become more commonplace. Another point which did come up in that Mentimeter poll is the complexity of natural systems and the difficulty, to be honest, of carrying out experiments in complicated natural systems. So this figure at the top right is something you might see in your statistics textbook or an undergraduate course. And there's sort of 18 identical blocks where you can choose to randomly allocate your treatments and carry out this really neat experiment. You then come to your conservation site on the ground, which might look something like this photo. And it's really difficult to reconcile how to try and carry out an experiment that in the ideal world would look like that in these messy landscapes. And I'm going to talk a little bit about how we can use experimental design to try and overcome that shortly. I guess organisational culture, I thought I would also mention, and I think it really relates to the previous 2 points. Do conservation organisations value including experiments, and therefore are prepared to allocate some resources to them and support their implementation. So yeah, and hopefully that's also increasing as well. I think one really key point to make is that planning experiments in advance is crucial, and to consider including an experimental component when planning conservation projects. Just thinking about, for example, the herbicide example, is it possible to slightly tweak what you're doing so that you can generate some new knowledge during it? So looking for opportunities where new knowledge can be produced for a relatively small amount of extra work. And I guess just to say that this is much more effective than trying to shoehorn an experimental sort of framing into a management and monitoring project that's already ongoing. That's much less effective at really creating the knowledge we need. So saying that you need to think about experiments in advance, what are the stages we need to think about? Firstly, identifying really clearly the question that needs to be answered. Secondly, creating an experimental design to answer that question. Thinking about how the data will be collected and analysed. Then having a moment of reflection and considering whether it's worth carrying out the experiment. And finally, but still in advance of actually implementing anything, considering what will be done with the results at the end of it. So I'll just briefly go through these stages with a few examples of projects on the ground and how they've included experimental components. In terms of identifying the question, generally conservation projects are really complicated. There's lots of different things going on, often overlapping in terms of time and space. And it's quite difficult to do an experiment across all of that and to separate out which action is relating to which outcome. So it's easiest to identify a single action that will be manipulated to look at the effect that has on results. And I'll just use a quick example to show how one of the projects that the Endangered Landscapes Programme is funding is including an experimental component. So this is a marine restoration project that is working on the Turkish coast in the Mediterranean. It's being run by FFI and AKD. And they're doing lots of different things, as I say. They're trying to create protected areas. They're trying to enforce the restrictions on fishing. They're removing ghost fishing gear. But they're also carrying out some transplants of macroalgae plants to try and restore the ecosystem. However, there's a problem with alien herbivorous fish grazing on these transplants. When they're small, they can't resist the rabbit fish grazing on them, and it's reducing the survival of the transplants. They've got a possible solution to this problem, which is putting cages over the transplants. However, this hasn't been done before. They don't know how long they need to leave them on for until the plants are big enough to be able to withstand the herbivory. And so to make the most effective decisions in the future, they decided to do an experiment to look at the different survival rates of the macroalgae after retaining cages for different time periods. And I'll come back to this experiment in a later stage. So once you've identified your question, the next thing is to think about how you're going to design an experiment to answer it. And I'm not going to, the main aspect of experimental design is to try and identify what are the results you're seeing that are due to the action you've taken and what's just background variation, what might have happened anyway in the absence of your intervention. So there's lots of textbooks and papers and all sorts of things, resources about experimental design, and I can't provide a comprehensive coverage of all of that, but I thought I'd try and talk about how some of it can be applied in the real world of conservation, particularly in relation to replication, controls, and how treatment and control units are allocated. So starting with controls, I expect we all know that the use of controls allows the effect of a treatment to try and be distinguished from what's going on without the treatment. And there are various ways to do that. The classic way is to have some places where you apply the treatment and some untreated areas. But you can also have comparisons of before and after. And another thing that can be really useful is a comparison of variants. So if you think something needs to be done, for example, in the invasive plant example, where you know you want to try and treat the plant, comparing the two different times of application can actually give you more information than maybe comparing the use of herbicide with no herbicide, where it would be kind of unsurprising if there wasn't a reduction in plant cover with the herbicide application. So this is a picture from the Turkish project I described earlier, where they're transplanting the macroalgae and having issues with grazing from the rabbitfish. So they decided to carry out a controlled experiment, including a comparison of variants. And they've got various sites where they're carrying out the transplants. And each one of those, they will have a set of plants, which are left uncovered as the untreated control, a set of plants they'll cage for 3 months, a set they'll cage for 6 months, and a set they'll cage for 12 months. And then they can go back and look at the survival and the herbivory of the plants under each of those treatments. This is quite a low effort experiment. They obviously need to put the cages out, but they're going to be visiting the transplants anyway for monitoring purposes. So all they need to do is ensure they remove the cages at the right time and record the results for each of the treatments individually. And the results can be used directly in decision making in future years in planning how they will manage the transplants and the protection of the transplants in the future. Moving on to replication, this is a really quite thorny issue. Statistically, the larger the number of replicates you can carry out for an experiment, the more accurate your result. And so basically you want to do as many replicates as you can often. But in conservation, there are often really substantial practical constraints and costs associated with carrying out replications. So it really depends on what the intervention is. But if you're carrying out something at a field site, at a field level, or at across a whole reserve, for example, it's really difficult to replicate that. And I want to talk a bit about thinking about whether that's still a useful thing to do, even if you can't carry out the ideal number of replications of a treatment. So it's commonly suggested you calculate the number of replicates you need from a power analysis. And this really boils down to looking at the expected effect size of your treatment and also the level of background variation. So if you've got a small effect size and a large high level of background variability, then you need to have a larger sample size. But I think in conservation practice, it's also worth thinking about a couple of other factors that might affect your number of replicates you include in an experiment. Firstly, what kind of action it is and what's practical. So this picture on the right-hand side comes from a project we're working with in the Carpathians in Romania, and they are introducing bison to the landscape. And it's not practical to think about replicating the reintroduction of a big species like that sort of 10s or 20s of times. It might be possible to do it maybe twice in 2 different areas or at 2 different times, but that's really all that's practical. I think it's also useful to think about the current state of knowledge. So if something's really novel, that may justify doing something even if it's not as statistically robust. So for example, something like putting up a nest box for a songbird, that's been done lots of times in lots of different places, and we've got a good evidence base. So putting up a couple of nest boxes and monitoring the effectiveness of that probably isn't very useful. Whereas arguably with the bison reintroduction, we don't know what the effects on the vegetation is going to be. So actually carrying out a before and after experiment of one site with that one reintroduction is still a valuable thing to do, and those results will be useful. This is a table that we put together as part of preparing a manuscript on this subject. And I've tried to colour code it a bit about the kind of level of replication that is informative or acceptable in different circumstances. And you can see that the column with many replicates is always going to be useful. So if at all possible, you want to carry out sort of 10+ replicates wherever possible. As you move left in the table and you move down to experiments with maybe a couple of replicates or even only one replicate, I think you need to think more carefully, but there still may be circumstances where that yields useful results. So for example, if you expect your effect size to be large, if it's a really novel intervention where there's not a good evidence base already, and if it's just not possible to replicate it. So this is really the only way of generating evidence. So I think the bison example probably falls into that. And I guess another thing to say about that is that if you carry out an experiment only at one or a really small number of sites, it does affect your scope of inference. So it's hard to draw conclusions about what the effects might be in other sites. But that can be overcome by using meta-analysis or drawing results from multiple sites together. So then you can start to look at patterns and overall effect sizes. So there can be real value in doing these single site studies under certain circumstances. And I thought I would give one example from a project we're working. In fact, this is the same project in Turkey being run by AKD. And one of the species they're working with is Mediterranean monk seal, which are an endangered species. And one of the limiting factors for their population, they think, is a lack of breeding sites. So monk seals breed in caves, and they need a dry ledge in the cave to haul out on and pup. And there aren't very many of these caves along this coastline. And the AKD team identified one of these potential caves that could be a breeding site, but it didn't have a ledge in it. And they decided to take this opportunity and install an artificial ledge in it. So this was something that hadn't been done before. It was only carried out at one site because they only found one suitable cave. But they did that and they monitored it carefully using a camera trap. And in the subsequent months, they found a female seal was using that dry ledge. So I think although this was an unreplicated experiment carried out at only one site in an opportunistic way, it's provided really useful information. And I think sharing those results will hopefully encourage others to try and carry out a similar intervention. And then they can try and understand the replicability of the result. And even think about things like altering the design of the ledge to see which is most beneficial for seals, which are used most, and even hopefully eventually, which one leads to greatest breeding success. The final aspect of experimental design I was going to touch on is allocating the treatment and control units across your replicates. So sort of the classic recommendation is that you use randomization and the treatment and control units are randomly allocated across the replicates. And this can work well, particularly if you have lots of replicates and either the site is fairly uniform or you don't know about any real patterns in background variation. So one example where this was used really successfully, this is a paper that was submitted to Conservation Evidence a couple of years ago, testing the effectiveness of 4 different types of nest box for birds of prey to breed in on the Mongolian steppe. So this is quite an open, large landscape, and that enabled them to put the boxes out on this randomised grid, as shown in the figure on the right-hand side. And each different symbol represents a different type of nest box. They then monitored the occupancy and breeding success across these boxes. And because of the randomised design, that allowed them to assess the preference of Sacred falcons, ravens, and upland buzzards for these different nest box types, and say that it's the box type they're preferring rather than any sort of habitat preference or anything like that. However, maybe more often, we don't have a uniform landscape. We have some kind of gradation, as in this box on the left-hand side, where the different colours could be, for example, different altitudes or different wetnesses along the site. And then if we can use a stratified allocation of treatments where we group the replicates into groups in each of the similar conditions and then randomly allocate the treatment and controls within each of those. And an example of those was the caging the transplanted macroalgae experiment. They carried out the transplants at multiple sites where the conditions may be different. But within each one of those sites, they randomly allocated the uncaged control and the cages that were put on for 3, 6, and 12 months. So that was a bit of a whistle-stop tour of a few aspects of experimental design. Another important thing to consider is thinking about the data you'll collect and how the results will be analysed. And I'm not going to cover that now, but just to say that it's a good idea to think about it in advance. And it can also be an occasion where it's useful to maybe reach out to local research institutions if you're conservation organisation is struggling for capacity with that, for example, student projects could be a useful part of contributing to that. The next stage I mentioned is this moment of sort of taking a step back and thinking about, is the experiment worth carrying out, and acknowledging that not all actions are appropriate to test experimentally, and thinking about the balance between the information that's going to be gained from the experiment and the cost of required to carry it out. This is a picture from a project we're working with the Zoological Society, and the main aim of the project is to try and create a protected area, but they're also doing some wetland restoration, so they're blocking old drainage ditches to try and increase water levels. And as I said, we're trying to encourage our projects to include experimental components. So we had lots of conversations with them to try and think about how we could manipulate maybe the drainage ditch blocking to learn something about it. But in the end, this is a really remote landscape. The scales are huge, and it's logistically complicated, and they have an effective way of blocking their ditches that they know works. So in this occasion, we decided not to include an experiment, just for the sake of it, really. So it's worth definitely weighing up the costs and benefits at this point. I'm just going to finish off by quickly talking about how we can use the results, the value of results that we can obtain from testing interventions, and how they can make a real difference to conservation practice. Firstly, results can be used directly in adaptive management. This is an example from the Cairngorms in the Scottish Highlands, and a lot of the project there is focused on trying to restore native woodland. Natural regeneration is really slow, probably mostly down to the thickness of the vegetation layer, and also high grazing pressure from deer. One proposed solution was that they could use burning, which isn't a commonly used intervention in this system. So the reserve management team created a randomised controlled trial where they looked at the impact of burning on native pine tree regeneration. And across the burnt patches, they found that natural tree regeneration was 10 times higher in the burned areas than the unburned areas. And this led to fire being included in the management plan of the, so it was applied in on the back of the results from the experiment, and that led to a big increase in regeneration of trees. In addition to using the results directly, it's also great if the results can be shared to improve practice across the wider conservation. And I touched on this earlier. Community written up, both in terms of having resources and also to ensure that negative or unsuccessful results are written up as frequently as positive ones, and to minimise biases in the evidence base. Results don't have to be shared in scientific journals. They can be put in reports, on websites, in data repositories. And evidence, also conservation evidence. In conservation science, there are easier to publish these studies than sort of conventional. Ecological practice. A few final thoughts. I'm not sure they're really conclusions, but really, I guess the main thing is to be alert for opportunities to include experimental components and to gain useful knowledge as for a reasonable expenditure as part of conservation practice. I think when you're working on conservation projects, you have a really unique insight into what knowledge is needed and where the evidence gaps are, and also the opportunity to fill them. Collaborations between academics and practitioners can be really brilliant, particularly for looking at large scale and complicated questions. But I think it's also important that we consider other opportunities to include experiments in sort of routine practice to increase knowledge incrementally. And the final point is just to reiterate that unexpected or sort of supposedly unsuccessful results are just as important and worthy of being shared as positive ones. It's as important that we don't replicate failure as that we learn from success. Thank you all very much for listening. I'd be very pleased to take questions.
Thank you so much, Nancy. That was really informative. That was very interesting. And there are some questions. And, given the time, I'll ask a couple of them. So I think one question that a lot of people have is about what was obvious from that word bubble, funding, money, as well as time. But there's some questions, and one comes from Chioma Chikere from Nigeria. And she's saying that she's working on environmental microbiology and experiments on bioremediation of petroleum contaminated soils. And the replication becomes very cost intensive because of the analyses, so not just the field work. And I'm wondering, are there strategies or ways, maybe specifically to this example, or more generally, how researchers or people working on applied problems can think about reducing costs, think about greater efficiency, making resources go a little further? Are there general principles?
I guess it depends very much on the intervention itself, whether there are ways of increasing sort of replication without sort of increasing the cost proportionately. I think one thing we could think about maybe more effectively is coordination. So if you've got different organizations working on similar things, almost treating those as replicates. So if you're doing something that is costly or large scale, so doing it at site level, if you're someone like Conservation International, you may have many different sites and you can apply it. But if you're a little local organization, you've only got one site, you can carry that test out. But maybe building a network of those organizations so they can share their data and sort of replicate in that way might be one model. And I guess the other thing is, it's really that difficult, hopefully are valid, and then using meta-analysis approach.
You sort of touched on that already. What's the role of the collaboration and interaction? And so somebody working on some sort of applied intervention, is there a strategy to ensuring greater success in implementing experimentation through collaboration? Are there certain types of
between academics and practitioners, or collaboration?
Whichever. Are there strategies that people should employ to help facilitate experiments through investigating the possibilities of collaboration, whether that's academic or other organizations?
Yeah, I think there's definitely value in that. I mean, I think there's a lot can be done to improve effectiveness in terms of identifying where we need experiments and feeding results back into practice. And it's all part of the same picture of trying to really increase conversations so that, I mean, I think there probably are a lot of experiments going on there that we don't know about. And I do understand there's a lot of time and effort that's required to communicate findings and to set up these sort of collaborations. And so I think, I mean, organisations like mine, organisations like the Cambridge Conservation Initiative, thinking about what things like applied ecological resources can do. Some people put their project plans up there and others could comment on them. Others could say, oh, I'm doing something similar. Should we try and maybe standardize our project design so we can compare the results, that kind of stuff. I think it's really important, but I think it's difficult. But I think also the way we're moving to now, lots of thick resources being online or being on platforms, there are ways to try and harmonize these things. Yeah, I think that can only benefit people.
Yeah, and another thought that I had on that, and I see there's a question that came in from Ben Sykes about this, is the funding. Certainly here in Canada, there are a number of funding mechanisms that explicitly fund academic, non-academic collaboration and problem solving, and so it might be a good idea for researchers wherever they are to see what kind of funding is available through different pipelines as well.
Yes, yeah, and absolutely. And you would hope that people who become conservation academics do want to do work that makes a difference on the ground. So one would hope they would be open to those kind of collaborations. But it's just creating the forum and the space for people to get into the same place and have time to have those conversations.
So maybe as a final question, there are some questions about I guess the limitations on running experiments, and so people are commenting about the number of replicates, the spatial scale, and one of the thoughts I had was, most people who are working in systems probably have a lot of intuitive knowledge about some of the effects and what's going on. Is there a strategy or way to leverage this non-independence between number of replicates and the magnitude of effect? And so what I mean by that is that if you know you're going to do something that's going to have a large effect, can you then get away with less replication or more limited scale, or should we always be going for maximizing the number of replicates or the spatial extent?
No, absolutely. I mean, I think if you're doing something that's going to have a large effect, I mean, that's kind of what power analysis does. If your effect size is smaller sample size, because you need less accuracy in your estimate of the effect size if it's sort of having a 10-fold difference compared to a 1.5-fold difference. So I think that absolutely comes in, and that table I put up, which I probably went through a bit quickly, talks about that as well. So it is the ratio of the effect size relative to the background variation absolutely determines what your sample size needs to be. And yeah, there are definitely examples in conservation where things have been done a small number of times, but they're really novel and they're really big, whether it's the wolves becoming back to Yellowstone Park, or looking at the impacts of maybe some of these natural experiments that take place have had really significant effects. And I guess one of the other things is to think about the mechanism involved. And if you understand the mechanism, it can also be helpful in linking up the causation between the action and the impact, even if your sample size isn't huge.
All right, so I think we'll have to leave it there, given the time. But Nancy, thank you so much for an interesting talk, and I think stimulating some interesting discussion, conversation, and maybe stimulating some thoughts and maybe future collaborations. I think this is a very fruitful type of conversation to have. Thank you so much.
Great, thank you.
All right, I'm going to just show a few slides to finish off today's AER Live. So that brings today's AER Live workshop to a close, and thanks so much to Nancy and to all of you for joining in and to the great questions. Our next and final workshop of the year will be on Friday, the 4th of December, jointly given by Dr. Namrata Shrestha and Dr. Luke Potgieter. Dr. Shrestha works for one of Canada's conservation authorities, and Dr. Luke Potgieter is coming from the University of Toronto. Their talk will be on prioritizing invasive plant management in an urban environment. So they'll be talking about management strategies and a prioritization tool. And registration is now open. If you've enjoyed this talk, you can get more involved with AER by visiting the website, and follow us on Twitter and LinkedIn for the latest updates about applied ecology resources and different initiatives that we're promoting. Finally, I'll leave you with the details of the offer from the sponsors of today's live workshop, NHBS, so that you can take full advantage. NHBS supply equipment and books for ecologists and conservation professionals, and they are offering free European shipping for AER Live viewers until the end of 2020. Okay, that brings us to end. see you again next month. Thank you.